Continuing the yesterday's lecture, that in yesterday's lecture we already make some introduction regarding the serial port programming in assembly language. So yesterday we discussed regarding some little bit about the baud rate there and which baud rates we are going to select, and for that baud rate, what are the timer 1 register values are there, that also we see yesterday there. Okay, in yesterday's class. So in today's lecture, we are going to discuss regarding the serial buffer and serial control register. Now the serial buffer register is one of the SFR. Okay, it is 8-bit. It is 8-bit there, and it is used only for serial communication. Okay. Now when we are to say that the serial buffer register is there, that is while we are sending the data from the controller and while we are receiving the data in a controller, at that time it is to be accessed there. Okay. When the byte of the data is transferred via the port 3, that is the TXT line. Okay, it is first place, it is in a serial buffer and then it is to be transmitted. Similarly, for the receiving, that is what is the byte of data is to be received. That is first it is kept, or we have to say that hold in serial buffer there. Okay, and then it is used for the further processing is there. So this is we have to say that here we have to say that the serial buffer plays a very important role for the communication of the byte of the data through the transmission line and through the receiver line. Okay, TXT and RST there. And there are the few examples are there that we have to say that how these instructions, this serial buffer is to be used in this assembly language there. So few instructions are given as for example here, that it is a move serial buffer #D. What it means that what is the data of the D, what is in a ASCII, it is loaded, it is in a serial buffer, that is it is utilized for the transmission purpose. At the same time, here the move serial buffer A, that is a copy accumulator into the serial buffer. Then move A serial buffer, that is a copy of the serial buffer data which is to be received, it is to be transferred, it is in an accumulator there. Okay, so these are the few instructions which we are utilizing for accessing the serial buffer. Detail what are there we are utilizing, this we can see it is in an example there. There is one example after this article, we see that. Okay, now when we have to say that is when you are the serial buffer, that is when we are transmitting the data, that is byte of the data first return, it is in the serial buffer when we have to go for the transmission, and as per our frame there, that is one start bit and one stop is to be attached there, and then it is to be transmitted. Okay. Okay, and similarly there for the receiver there, that is when the data is to be received, that is a frame is to be received. So what is to be done here, it is that in a serial buffer only the byte of the data is to be placed, removing the start and the stop bit. That is while the transmission the data, we are framing the data with the start and stop bit. So what is the byte of the data, it is in a serial buffer, it is to be framed with the start and stop bit, and when it is to be received, it is deframed. It is deframed in the sense start and stop bits are removed and only the byte of the data we are going to place, it is in a serial buffer. म्हणजे काय होतं इथं, सिरियल बफर रजिस्टर जो काय आहे तो डेटा ट्रान्समिशन, दॅट इज बाईट ऑफ द डेटा ट्रान्समिशन अँड द बाईट ऑफ द डेटा रिसिव्हर ह्यामध्ये की रोल करतो. तर ज्यावेळेस तुम्हाला डेटा हा ट्रान्समिट करायचा असतो त्यावेळेस त्याला आपल्या प्रोटोकॉल प्रमाणे त्याला एक स्टार्ट आणि एक स्टॉप बीट अटॅच करावं लागतं. सुरुवातीचं स्टार्ट बीट आणि शेवटचं एक स्टॉप बीट. स्टॉप बीटचे आपल्याकडे 2 ऑप्शन आहेत, पण आपण त्यापैकी एक ऑप्शन वापरणार, म्हणजे एकच बीट वापरणार आहे, 2 बीट वापरणार आहे ओव्हरहेड्स कमी करण्यासाठी. ओके. तर ज्यावेळेस तुम्ही पाठवत असता त्यावेळेस सिरियल बफरमध्ये बाईट ऑफ डेटा हा स्टोअर केलेला असतो. मग तो बाईट ऑफ द डेटा जो काय आहे तो काय केला जातो, परत पाठवत असताना TXT लाईनवरती एक स्टार्ट अँड स्टॉप बीट त्यामध्ये ऍड केलं जातं. काय केलं जातं, एक स्टार्ट आणि एक स्टॉप बीट ऍड केलं जातं. आणि ज्यावेळेस तुम्ही डेटा रिसिव्ह करता, ज्यावेळेस तुम्ही डेटा रिसिव्ह करता त्यावेळेस ऍक्च्युली जी काही फ्रेम आलेली असते त्या फ्रेम मध्ये ऑलरेडी एक स्टार्ट बीट आणि स्टॉप बीट असतं, एक स्टार्ट बीट आणि एक स्टॉप बीट असतं. तर ज्यावेळेस तुमची फ्रेम ही रिसिव्ह होते, ज्यावेळेस तुमची फ्रेम रिसिव्ह होते त्यावेळेस सिरियल बफर मध्ये फक्त बाईट ऑफ द डेटा स्टोअर केला जातो आणि त्याचं जे स्टॉप आणि स्टार्ट बीट आहे ते रिमूव्ह केलं जातं. ओके, म्हणजे ते रिमूव्ह करून आपण ते काय करतो, स्टोअर करतो. ओके ओके, this is about the start bit and this is about the serial buffer. Now we have to go for the serial control register. Already this serial control register we already discussed, it is in a first topic in small content there. Right now also we are going to see it is in somewhat detail there, because right now we are utilizing this as a serial control register here. Okay, so the serial communication register is an 8-bit register used to program the start bit, stop bit, and data bit of the data framing, and among other things there. The serial communication register. Okay, so you remember that it is 8-bit, and at the same time it is to be bit addressable. It is to be bit addressable as per your the thing. So this is the structure is here. There is a structure is SM0, SM1, SM2, receive enable. Then you have to take your this actually transmit bit, receive bit, yeah? And your the transmit interrupt and receive interrupt is there. Okay. So these are to be 8 bits are there. Okay. So right now here we go, it is one by one there. Okay. So first is that the SM0 and SM1. It is the D6 and D7 registers are there. D7 and D6 register. These two are here. As here, these are the 2 bits. So these 2 bits are here is utilized for your the framing your the frame there. That is how you have to frame this data is to be there with one stop bit and start bit is there. We can see it is here. So if you take your the SM0 and SM1, if these 2 bits combination we have to make, we have to get in the 4 serial communication modes are there. That is the serial mode 0, it is mode 0. Then you have the mode 1 is, that is the serial mode 1 is there. It is a 8-bit data, 1 stop bit and 1 start bit is there. Okay. Then you have the mode 2 is there. That is the serial mode 2. It is 1 0 and 1 1. It is a serial mode 3 there. Okay. So the normally here what we have to say that the mode 0, mode 2 and mode 3 are there. These are rarely utilized. But the normally here we are utilizing the mode 1 is there, because it is the 8-bit data, 1 stop bit and 1 start bit is there. Okay. So this we are going to utilize that. Then if you have to go for your the D5 bit. Now the D5 bit is your the SM2. It is a, now when we have to say that there is the multi-processing situation is that is we are taking the communication in between the processors there. At that time this SM2 line is utilized, and if it is not utilized then we have to put it is to be 0 there. म्हणजे SM2 ही जी लाईन आहे ही लाईन आपण रेअरली वापरणार आहे. आता सध्याच्या आपल्या सिलेबसच्या आउट ऑफ स्कोप आहे. त्याचं कारण असं आहे की सिलेबस प्रोसेसिंग आपण इथं करत नाही आता, बरोबर. फक्त आता एकच कंट्रोलरचा आपण वापर करतोय, त्याच्यामुळं फक्त आपण SM1 आणि SM0 हे दोनच वापरणार आहे, बाकीचे वापरणार नाही त्या. ओके, तर आपण वापरणार नसल्यामुळं ही D5 बीट जे आहे SM2 हे आपण झिरोच करणार, बिकॉज इट इज युटिलाइज, इट इज इन अ मल्टी प्रोसेसिंग इन्व्हायरमेंट द्या. नाउ द आता पुढचं बीट REN, that is receive enable. It is receive enable, it is D4 bit is that. Okay, that is, if you are not make it is 1, if you are not making it is to be 1, then it is to be your the this serial communication is not working there. Serial communication is not working. That is, when we are considering about your the serial communication is there, at that time we have to require to receive enable pin must be 1 there. Receive enable pin must be 1, and we have to make it is 1 with the help of the instruction, that is your the set bit scon.4 and clear scon.4 is to be there. Okay, this we have to we are going to do here. Okay, so whenever we have to take your the communication there, for this communication we are requiring your the receive enable bit must be 1. Either we have to go for your the receive the data, or we have to go for your the transmit the data. Okay, otherwise it is to be disabled. Okay, that is, we are not utilizing your the serial communication there. In such situation, this is to be 0. Then you are the TB8, that is, this is the bit number 3. It is a transfer bit 8. Actually, it is also not utilized here. Okay, so we are not going here for this. तर आपण काय डिस्कस करत होतो की TB8 आणि RB8, receive bit 8 and transfer bit 8 is to be there. Okay, these are the bit 2 and bit 3 are there. But actually, these two bits are normally utilized for your the mode 2 and mode 3 there. And we are not going to see here as a mode 2 and mode 3 there. So it is further beyond the scope of our application there, beyond the scope of our application there. Okay. So here we are putting your these two bits, that is D3 is equals to 0 and D2 is also equal to 0 there. Then your the two another bits are that it is a D1 and D0, that is your the transmit interrupt and receive interrupt. Now regarding this, we already discussed, it is in a last topic, that is the fourth topic. Still we are going to discuss little bit here there. Now this transmit interrupt, that is when we are transmitting your the frame there. So when your the 8-bit data which is to be transmitted, it is finished there, then it is successfully transmitted. That's why this transmit interrupt flag will be raised 1 there. It becomes high. And it says that right now the controller is ready for transmitting the second frame is there. Okay, when your this TI flag is 1 there, that it indication that the data is already transmitted successfully, so device is ready for the transmission of the next data. Okay, and automatically through the when your the next byte of the data starts transmitting, it becomes 0 here, and after the successful transmission further it raised to 1 there. Then you have the receive interrupt. Okay, now this receive interrupt is again same as that of, that is when your the data is to be received successfully, when the data is to be received successfully and it is to be placed, it is in a serial buffer, then your the receive interrupt flag is becomes 1 there. It is 1 there. Okay, and further it will be becomes 0 automatically through the program there. Okay, so this about your the transmit interrupt flag and receive interrupt flag is there. Now here we are going to see that one how we are doing your the serial programming. So what are your the steps are there for the serial programming? So here we see that you have the serial buffer register and serial control register. Okay, now how the serial programming is to be done for your the transmission of the data. So the first is that the here first load the value of tmod. Load the value of tmod. That is here. It is the tmod value for your the baud rate. It is for the baud rate is to be. That is, this will be define your the baud rate is to be there. Then what we have to go then? There is a th is loaded in one of the value. Okay. Then baud rate value is to be loaded. That is, which is your the baud rate is to be there. Either that is from this table we have to choose one of the value, that is FD, FA, F4, EF, depends upon what is your the baud rate. But the normally we have taken the baud rate is the 9600, so it is FD is to be there. It is FD is to be there. Okay, so this we have to load it here in TH value. Then serial communication resistor, serial control resistor is also loaded because its value, that is, it is for your the in which mode, and the receive enable is to be there. That's why it is to be 50, indicating that you have the mode 1 8-bit data framed with start bit and stop bit. Then start the timer. That is the we have to get your the baud rate. Start the timer is there. Then TI is to be cleared. That is when you are the we are going to clear the TI flag. That is, we are ready for your the transmission there. Then character byte to be transmitted serially is written into the serial buffer. And when it is in a transmission process, so we have to check either it is your the TI flag is to be raised to 1 or not. That is when your the transmission is successful. When your the transmission is successful, at that time the TI flag becomes 1. At that time the TI flag becomes 1 there. Okay, when your the transmission is to be successful. And after this we have to go for the next as a step number 5 there. So how it is to be working, that we are right now we are going to see it is in this one program there. So in this program, that is, this program is written for what purpose? That also we see it is first time it is 10.2. Okay, now here write a program to transfer a letter Y. Write a program to transfer a letter Y serially at 96 baud rate continuously. So here we are going to select the baud rate of your the 9600. Okay, so we are requiring it is the value is to be here. It is the FD there. We are requiring the value is to be here. The FD is there. It is a 96. Here it is to be FD there. Okay, so this we have to select. Then and also to send a letter N through port 0. Also send a letter N through port 0. Port 0 module letter N send करा, which is connected to a display device. Which is connected to a display device. Which is connected to a display device. So this is your the configure. That is how it is to be circuit is to be there. That is, we are going to send through your the transmission line, that is 3.1 port 3.1 Y letter is to be there, and for your the port 0 we are going to continuously send the letter no, that is the N letter is to be there. So how it is to be that program, here we have to see it is move tmod 20h in the sense what, now here it is the tmod value is 20 in the sense timer 1 in mode 2. Timer 1 in mode 2, it is in a auto reload mode. That is your the 8-bit auto reload mode. It is 8-bit auto reload mode. So here it is 20h is to be there. Then move th1. Here it is in a decimal. We are not utilizing the decimal. Here we are writing fdh. We are not writing it is the -3. We are going to write it is to be FDH. -3 also it's okay, but we are dealing it is in a hex there. So we are not considering about this decimal number as a negative decimal. And -3 is nothing but your the FDH. Okay, if you see that. So it is for your the baud rate selection there. That bit is to be there. Then you are the move serial communication serial control register. It is 50H there. That is, it is in a mode 1. There is one stop bit, one start bit, 8 bit of the data, and renew is enabled there. Receive enable is to be enabled. So it is to be 50. So if you see that here in this, here it is 01, 01, and rest of the things are the 0. That's why it is to be 20. That is, it is 01, 01. That is, receive enable is 1, SM is 1, SM0 is 0, SM2 is 0, and rest of these 4 nibble lower nibbles, these are also 0 there. That's why it is to be 20 is there. It is the 20 is there. Sorry, it is the 50 is there. Okay. Then start the timer. Then start the timer. Okay. Then move buffer. There is a serial buffer Y. That is, what is your the violator and its ASCII code. We have to transfer it is in a serial buffer. आता जे आपल्याला पाठवायचं आहे, जे आपल्याला सिरियली पाठवायचं आहे, ते आपल्याला काय करायचंय, सिरियल बफर वरती पुट करावं लागेल. बरोबर. आणि सिरियल बफर काय करेल, तो आस्की डेटा जो आहे मोड 1 वरती असल्यामुळे काय होणार आहे, तिथं तुम्हाला एक स्टॉप बीट आणि एक स्टार्ट बीट ह्याला ते पॅक करून 10 बीटची फ्रेम ते काय करेल, ट्रान्समिट करेल. दॅट इज अ मूव हिअर. सो मूव सिरियल बफर वाय. JNB TI here. In the sense, we have to continuously tracking for transmit interrupt flag. If the transmit interrupt flag is not 0, in the sense it is in a transmitting process. It is in a transmitter process. When it is in a completed, that is when you are the 10 bit of the data, after your the frame is to be completely transmitted, then and then the transmit interrupt flag becomes 1. And once it is becomes 1, it immediately come out of this loop and it clear the TI flag. It clear the TI flag. Okay. That is, it is for the ready for your the next byte of the transmission. Then you are the move for the port P0. Port P0 तुम्हाला काय पाठवायचं, move N to port P0 for the parallel transfer. That is, we are going to transfer your the N letter for the port 0. Then short jump again. Short jump again. That is, repeat this process. Repeat this process. So it is continuously transmitting the data here that we are going to see here. Okay. So this is the one example there. Also, we can take your another example is here. Another example is what? See, for your the serial data transmission. It is another example. Take data through port 0, 1, 2. One after the other. म्हणजे प्रत्येक पोर्ट मधून डेटा तुम्ही घ्या. ओके. टेक डेटा थ्रू अँड ट्रान्सफर दिस डेटा सिरियली कंटिन्युअसली. आणि तो डेटा कंटिन्युअसली तुम्ही काय करा, ट्रान्समिट करा. ओके. तर सी हाऊ इज द प्रोग्राम. देन मूव टी मोड. म्हणजे इथे परत काय झाला, टायमर 1 2 मोड बॉड रेट साठी. नाउ हिअर फर्दर वी हॅव टू गो फॉर युअर द मूव TH. It is -6. Here they have to put it is to be 48, but actually we are taken it is a always it is the FD there. We are taken it is always as a FD there. We are not going to consider about the this another term, that is your the 4800. This 4800 is nothing but your the FA there. Now this baud rate selection is depends upon the designer there, but always we are going here it is the 96 baud rate, so it is the FD is to be there. Okay. Now then you have the serial control register. Then you have the serial control register. Further you have the 50 as in the previous example here. That is the 8 bit in mode 1 and receive enable is to be there. Now the 3 ports we have to put it is in an input port. That is the move P0 FFH, move P1 FFH, move P2 FFH. In the sense what, all ports we have to make it is in a इनपुट मोड, दॅट्स वाय इट इज FF. म्हणजे हे इथं असाइन काय केले, सगळे पोर्ट्स FF करून काय केले, इनपुट म्हणून असाइन केले. देन सेट बिट, स्टार्ट द टायमर फॉर द बॉड रेट. देन मूव्ह, व्हॉट मूव्ह, P0 चा डेटा अक्युम्युलेटर मध्ये यायला पाहिजे. P0 चा डेटा काय कुठे यायला पाहिजे, अक्युम्युलेटर. अँड ऍब्सोल्यूट कॉल सेंड, आणि तो डेटा आपल्याला काय करायचा आहे, सेंड. आणि आपल्याला कसं सेंड करायचं, इथं काय सांगितलंय, वन आफ्टर द अदर. म्हणजे पहिल्यांदा P0 चा डेटा गेला पाहिजे, परत P1 चा डेटा गेला पाहिजे, परत P2 चा डेटा गेला पाहिजे, बरोबर. म्हणजे हे कंटिन्युअसली आपल्याला काय करायचं, ट्रान्समिट करायचंय. तर आता इथं आपण काय केलंय की ट्रान्समिशन साठी एक सबरुटीन तयार केलंय, ऍब्सोल्यूट कॉल सेंड. तो सेंड इथं काय, मूव्ह, म्हणजे अक्युम्युलेटर मध्ये आलेला डेटा हा सिरियल बफर मध्ये ट्रान्समिट करा. जोपर्यंत ट्रान्समिट इंटर फ्लॅग हे इनेबल होत नाही तोपर्यंत लूप मध्ये राहू द्या. when it is to be 1, in the sense your the data is to be transmitted and the device is ready for your the next byte of the transmission there. Then you are the clear TI, then clear TI for the next transmission, and repeat this process. So we have to say that is a return, that is return, further it comes here. Then move P1 to A, परत P1 चा डेटा A मध्ये पाठवा. ओके, P1 चा डेटा कुठे पाठवा, A मध्ये पाठवा. देन ऍब्सोल्यूट कॉल सेंड, ऍब्सोल्यूट कॉल सेंड द्या, म्हणजे परत सिरियली पाठवून द्या. परत मूव्ह A P2, म्हणजे P2 चा डेटा परत अक्युम्युलेटर मध्ये घ्या, ऍब्सोल्यूट कॉल सेंड, ऍब्सोल्यूट कॉल सेंड. म्हणजे परत हे सिरियल ट्रान्समिशनचं सबरुटीन कॉल, म्हणजे इथं 3 वेळा सिरियल ट्रान्समिशनचं सबरुटीन काय केलंय, कॉल केलंय. आणि शॉर्ट जम्प टू रिपीट, म्हणजे शॉर्ट जम्प टू परत रिपीट. म्हणजे ही प्रोसेस काय होईल, तर कंटिन्युअसली ऑन राहील. म्हणजे P1 चा डेटा घेतला, बाहेर पाठवलं, P0 चा डेटा घेतला, पाठवून दिला, P1 चा डेटा घेतला, पाठवून दिला, P2 चा डेटा घेतला, पाठवून, परत P0 चा डेटा घेतला, सिरियली ट्रान्समिट केला. सो दिस इज द टोटल द प्रोसेस व्हॉट वी आर गोइंग टू सी हियर. ओके, तर फॉर द